Have you ever wondered about the precise moment you fall asleep? Not the feeling of being tired, not the dream you wake up from, but the exact, fleeting instant when your conscious mind releases its grip and you drift away. It's not a switch being flipped. It's a delicate, intricate dance happening deep within your brain, a cascade of neurological events that carry you from one state of being to another. Tonight, let's journey into that quiet abyss, into the soft, silent seconds where wakefulness dissolves into the first whispers of sleep. What is truly happening inside your head during that final, conscious thought before you surrender to the night? The transition from the world of wakefulness into the realm of sleep is a subtle, yet profound, shift in the very rhythm of your mind. As you lie there, with your eyes closed, your brain isn't simply shutting down. It's changing its frequency, like tuning a radio to a different station. In these final moments of awareness, your brain is dominated by alpha waves. You can think of these as the gentle, idling hum of a mind at rest, relaxed but still awake. They are the signature of calm contemplation, the quiet echo of your day fading away. But as you drift closer to the edge, something remarkable begins to happen. These steady alpha waves start to fragment, giving way to a new, slower, and more erratic pattern, the theta wave. This is the true neurological marker of the threshold. It's the moment your brain officially enters stage 1 sleep, the lightest and most fragile phase. You are no longer fully awake, but you are not yet deeply asleep. You are in the liminal space, the soft, blurry vestibule of the mind, where the boundary between the inner and outer world begins to dissolve. This transition isn't instantaneous. It's a gradual descent, a slow, rolling tide of theta activity washing over the shores of your consciousness, pulling you gently out to sea. As theta waves begin to dominate your cortex, you enter a strange and fascinating twilight zone known as hypnagogia. This is the state where you might experience peculiar, dream-like fragments of thought, hear phantom sounds, or see fleeting images behind your closed eyelids. It's also the stage where you might suddenly feel a jolt, a sensation of falling, followed by a violent muscle spasm that snaps you back to attention. This is a hypnagogic jerk. Scientists believe these jerks are a kind of evolutionary misfire. As your muscles begin to relax profoundly, your brain, specifically the reticular activating system which governs arousal, momentarily misinterprets this rapid relaxation as a sign that you are physically falling. In a split second, reflexive panic, it sends a powerful nerve signal to your limbs to catch yourself, causing that sudden, startling twitch. It's a primal survival instinct intruding upon the delicate process of surrender. A ghost from our evolutionary past when falling from a tree branch was a genuine nocturnal threat. This sensation of falling in a dream isn't a dream at all, but rather your brain's confused, last-ditch effort to keep you safe as you cross the threshold into sleep. As your mind continues its descent past the jolts of hypnagogia and into deeper stages of sleep, your brain must solve a critical problem: how to keep your body still while your mind roams free. The solution is a remarkable feat of neural engineering called atonia, a state of temporary and near-complete muscle paralysis. This process is orchestrated deep within the brainstem, in a region known as the pons. As you enter REM sleep, the stage where vivid dreaming occurs, the pons sends inhibitory signals down the spinal cord. These signals act like a firewall, actively blocking the motor neurons that would otherwise command your muscles to move. This neural blockade is essential. It prevents you from physically acting out the narratives of your dreams, ensuring you don't leap out of bed to chase a phantom rabbit or swing your arms to fight an imaginary foe. It is the brain's own sophisticated safety mechanism, a biological straitjacket that protects you from your own subconscious adventures. The body is quieted, rendered immobile, so that the mind can run wild in its own private theater, safe and sound. At the very heart of this nightly transition are two small but powerful structures, working in perfect synchrony: the thalamus and the pineal gland. Think of the thalamus as the grand central station of your brain's sensory information. Throughout the day, it relentlessly relays sights, sounds, and sensations from the outside world up to your cortex for processing. But as you begin to fall asleep, a specific part of the thalamus, the reticular nucleus, acts as a gatekeeper. It begins to inhibit the flow of the sensory data, effectively closing the gates to external stimuli. The world outside begins to fade not because it has gone quiet, but because your brain is no longer listening. Meanwhile, in response to the diminishing light detected by your eyes, the pineal gland ramps up its production of melatonin. This hormone doesn't force you to sleep, but rather signals to the entire body and brain that it is nighttime, facilitating the transition. The thalamus quiets the outside world, while the pineal gland announces the arrival of darkness, together creating the perfect internal environment for sleep to take hold. For most of us, the descent into sleep is a smooth, unnoticed transition. But for some, this boundary is a place of unnerving awareness. This is where the phenomenon of sleep paralysis occurs. Sleep paralysis is essentially a glitch in the system, a temporal desynchronization between mind and body. It happens when the brainstem-induced muscle atonia, the paralysis meant to protect you during REM sleep, either begins too early as you're falling asleep, or lingers too long as you're waking up. Your mind becomes conscious, your eyes may even open, but your body remains locked in the immobilized state of sleep. You are awake, but unable to move or speak. This terrifying experience is often accompanied by hypnagogic or hypnopompic hallucinations, the lingering dream fragments which can manifest as intruders in the room, or a heavy pressure on the chest. It's the ultimate state of vulnerability, a waking nightmare where the mind is trapped inside a sleeping body, caught right on the jagged edge between two worlds. The delicate ballet of falling asleep is usually graceful, but in certain neurological conditions, the choreography falls apart. Consider narcolepsy, a disorder characterized by overwhelming daytime sleepiness and sudden sleep attacks. In a narcoleptic brain, the transition from wakefulness to sleep is abrupt and chaotic. Instead of a gentle descent through the stages, a person with narcolepsy can plummet directly from full wakefulness into REM sleep within minutes. The brain's regulatory switches, particularly a chemical called orexin which governs arousal, are deficient. This means the normal boundaries are broken. The muscle paralysis of REM sleep, or cataplexy, can intrude into waking life, triggered by strong emotions like laughter or surprise. The vivid dreams of REM sleep can spill into consciousness, causing intense hallucinations. Narcolepsy provides a dramatic illustration of what goes wrong when the carefully managed, step-by-step process of sleep onset is bypassed, revealing just how crucial that orderly, gradual descent truly is for a stable mind. Modern neuroscience has given us an unprecedented window into this mysterious process. Using high-density electroencephalography, or EEG, researchers can watch this transition unfold in real time. On the screen, the vibrant, high-frequency beta waves of an active, awake brain appear as a dense, chaotic scribble. As the subject relaxes, the scribble smooths into the rhythmic, rolling hills of alpha waves. Then, as sleep begins, we see the first incursions of theta, slower, larger waves that look like deep, gentle swells in a calm motion. Functional MRI scans add another layer, showing a decrease in activity in the prefrontal cortex, the seat of our executive function and conscious will, while areas like the thalamus and brainstem light up, busy managing the shutdown sequence. These glowing, pulsing images are not just data, they are the visual representation of your consciousness receding, a map of the mind turning inward as it prepares for its nightly voyage. But what happens if this delicate process is disturbed? An unexpected noise, a touch, or sudden worry can easily derail the journey into sleep. When interrupted during stage 1, the brain can snap back to full alertness almost instantly. The nascent theta waves are immediately replaced by the sharp, jagged beta waves of arousal. Your heart rate might quicken, and you'll feel a jolt of awareness, the feeling of being pulled back. This interruption resets the process. The thalamic gates fly back open. The cortex re-engages with the external world, and the slow descent must begin all over again. Frequent interruptions, whether from noise, stress, or a condition like sleep apnea, prevent the brain from ever reaching the deeper, restorative stages of sleep. It becomes trapped in a frustrating loop, constantly attempting the descent only to be thrown back to the surface. This is why a fragmented night leaves you feeling exhausted, even if you've spent hours in bed. The journey was started many times, but never completed. So the next time you find yourself lying in the dark, on the cusp of sleep, remember that you are not simply shutting off. You are initiating one of the most complex and elegant biological processes known as science. Your brain is meticulously shifting its rhythm, quieting the world, paralyzing your body, and preparing your mind for the theater of dreams. It is a surrender, yes, but it is an active and intricate one. A silent, nightly migration from one form of consciousness to another. And as you feel that final, heavy pull, that last coherent thought slipping away into the soft, velvet darkness, you can rest assured that your brain is standing guard, managing the delicate and profound journey into the quiet and necessary abyss. Sleep well.